Hello guys, welcome to the DMS online school. In today's video we are going to revise science paper 2, the paper which was written on the 13th of November 2023. The paper reads Examinations Council of Zambia, examination for school certificate ordinary level. So this is the paper that was written by the grade 12 internal candidates last year. So if you are new to this channel, you are most welcome, and on this channel I teach science, biology, mathematics, civic education, English, RE, and also revise past examination papers just as I'm doing in this video. So if what I do on this channel is what you're interested in, please consider clicking the red subscribe button below and turn on the bell notification so that when I upload a new video, YouTube will be able to notify you that the DMS online school has uploaded a new video. So without further ado, let's go straight into this wonderful revision. Okay, so this is section A, which consists of 20 multiple choice questions. So A1 reads, a learner accidentally spills an acid on his clothes. Which of the following is the most appropriate action to be taken by the learner? A learner accidentally spills an acid on his clothes. Which one of the following is the most appropriate action to be taken by the learner? A. Quickly wash off the acid with water. B. Report to the teacher and the laboratory technician. C. Rush to the school clinic. D. Take off the clothes very quickly. Alright, so when a learner accidentally spills acid on their clothes, the first thing that they should do, which is very important, is actually to quickly wash off the acid with plenty of water before they can report to the teacher or laboratory technician or rush to the clinic or take off the clothes. The first thing is to wash the clothes with plenty of water, to wash off the acid with plenty of water. All right, so the correct answer here is A. Then we got to A2. So A2 reads, a beaker containing 200 cubic centimeters of water was made to stand for 1 hour as shown in the following diagram. So we have a beaker here with 200 cubic centimeters of water, which was made to stand for an hour. So at the start of an experiment, the beaker had water level to 200 cubic centimeters, and then after an hour, the beaker had water level to 160 cubic centimeters, implying that it has lost it had lost 40 cubic centimeters of water. All right, now the question says, which process took place in this experiment? Okay, what happened for the water to be lost from 200 cubic centimeters to 160 cubic centimeters for an hour? So here they're saying A, the process which took place is actually boiling, B, condensation, C, evaporation, D, melting. Okay, so this question got me thinking for me to arrive at the answer that I gave, because at first I had thought the answer was supposed to be evaporation. Okay, then I looked at the amount of water that was lost just within an hour. So is it possible that if you leave, for instance, a beaker of 200 cubic centimeters water for an hour, when you come back it would have lost 40 cubic centimeters of water? I thought this water was just too much. So for me, logically thinking, I thought the process could have been boiling. That can happen in an hour. It is possible that the beaker can lose 40 cubic centimeters of water. So my answer here was actually A here. All right, so let's move to the next question. Question A3 reads, it was suspected that a substance X was one of the three substances J, K, or L. Spots of each substance were put on the starting lines of two pieces of chromatograph paper. One paper was developed with water and the other with ethanol. To find diagrams, the final diagrams are shown. Okay, so here is a situation, guys. We have substance X, which is suspected to have three substances J, K, or L. So to verify that, they had to carry out paper chromatograph on using two different solvents. Okay, so we have paper chromatography diagram 1 where they used water, and then we have diagram 2 where they use ethanol. So all the substances were placed on start line here, J, K, L, X, and then after some time, this is how they had moved, okay, along the filter paper. And here also they had used ethanol, and also this is how these substances had moved. So here we see that X, L, and K had moved the same level from the start line, while here we see that X and K had moved the same, and J had moved the same level from the start line as well. So the question says, what is X? Okay, so for X, L, and K to have moved the same distance from the start line here, it means they have the same solubility, okay. And then when they tried using a different substance, actually it is again J, K, and X that had moved the same water level. But here we see that K moved the same water level with that of X, and here also K maintained the same level. So here we see that J did not move, but here J has moved. Here we see that L had moved, but here L has not moved. So the only substance that has maintained consistent with X is K. Here K and X, they had the same water level, and here also K and X had the same levels of movement. So this implies that X and K are one and the same substance. So when they say what is X, we can say that A, J only, which is not true, B, K only, which is correct. So X is actually K, so the answer is B. We move on to the next question, which is A4, which says which mixture of substances can be separated using a magnet? Which mixture of substances can be separated using a magnet? A, iron filings and sodium chloride, then B, sawdust and sodium chloride, then C, sodium chloride and iron 2 chloride, and D, sodium chloride and sand. Okay, so the separation technique that uses magnetism is actually depends on substances that have got magnetic properties that can be attracted. So when we look at these, only iron filings have magnetic properties. So if you mix iron and sodium chloride, which is actually salt, it is very possible that these can be separated because iron filings can be attracted to the magnet while sodium chloride cannot. So the correct answer is A here. So guys, if you're enjoying this revision, please consider giving this video a like and also share to your friends in WhatsApp groups, on Telegram, or also even on other social media platform. And also let me know in the comment section. If you haven't subscribed yet, please consider clicking on the red subscribe button below and turn on the bell notification so that you don't miss out other uploads that I'm going to make on this channel. And also for those doing online tuitions, GCE, remember that this time we are almost going into the exams, so I have started a robust revision, or what I call a vigorous revision, which is based on topic by topic revision, so that if you are not ready through the topic by topic revision, you will be able to be prepared to go for the examination, right? So if you're interested to join in this remaining 2 months for quick revisions, you just have to WhatsApp me on 0977 924175 so that you can be added to the Telegram group that I'm using to do the revisions. All right, so let's go to question A5. A5 says, why are isotopes said to have the same chemical properties? This is because they have the same number of okay, let's read again. Why are isotopes said to have the same chemical properties? This is because they have the same number of actually they should have the same number of electrons, because electrons are the one that determine the characteristics of the chemical characteristics of an atom. So in isotopes, you know, isotopes are atoms of the same element which have the same atomic number but different mass numbers. So if they have the same atomic numbers, then it means they have the same number of electrons, and electrons are the one that determines how an element reacts. whether it can lose electrons or it can gain electrons. So the correct answer when they say why are isotopes said to have the same chemical properties, this is because they have the same number of electrons. So the answer is A. So we move to A6, which says which radioactive isotope is used in industry to indicate that the drink can is full during production. Okay, which radioactive isotope is used in industries to indicate that the drink can is full during production? Okay, so for me, I don't know actually the answer here, because even when I tried to do some research, I found different answers to this question. So when we teach the uses of isotope, I think isotope have got various uses. So such questions like this one, they're wrong questions, because you may find that these elements here can produce alpha radiation, they can produce a gamma radiation, they can also produce beta radiation. You can find maybe cesium, iodine, and uranium can do all those three. So, and all those three, like maybe gamma rays could be the one that can be used to test or to indicate if a can is full during drink production. So if all of them are doing that, and then you want one person to choose one, we don't teach like that. So such questions are not good questions on the examiner part. These are poor techniques. Okay, these are poor techniques. At least you should do such questions like this one, use something which is common, like maybe which radiation is used to treat cancer. Okay, so that one is very, very common, that we use gamma ray radiation mostly to treat cancer. So, or which substance can be used to measure thickness or can be used in alarms. That one is very common. We don't talk about this drink measurement when it is full, which one can be used. So for me, this question was a very poorly questioned. So however, through some research, I discovered that maybe it could be iodine. That is what I saw there when I did some research. But however, I wasn't pleased with how this question was asked. Then A7 says, which of the following is a property of the hydroxide ion? This one. Then they are saying it, A combines with hydrogen ions to form water. Then B is present in an acid. No. Then C is present in water. Then D readily breaks down into hydrogen ions and oxide ions. No. This hydroxide, actually, the best option here is that combines with hydrogen ions to form water. So the correct answer is 7 here, I mean A. So we move to A8, which says, which net ionic equation represents the reaction of calcium hydroxide solution with dilute hydrochloric acid? Okay, so which net ionic equation represents the reaction of calcium hydroxide solution with dilute hydrochloric acid? All right, so they want the net ionic equation. So let me just try to see if I can teach something on net ionic equation here. So let me just do this. Of course, there will be some noise, sorry for that, because I'm trying to use my pen. So let's do the equation here for, I'm going to do it here for calcium hydroxide is like this. Calcium hydroxide should be aqueous. It's the one reacting with dilute hydrochloric acid. Okay, sorry, let me just erase this one. It's like I'm cancelling. So dilute hydrochloric acid. So plus dilute hydrochloric acid is like HCl aqueous as well. So this one now gives us calcium chloride like this, which can be aqueous plus water. Okay, because this is a base and an acid. A base and an acid will give you a salt and the water. So we can balance this equation: calcium 1, hydroxide, I mean oxygen 2, here oxygen 1. So we can add the 2 here. So here we go to a hydrogen 2, here hydrogen 4, so we'll add a 2 here so that to make hydrogen 4 here. Then also, yeah, chlorine 2 here, even here too. So now in ionic equation, these in aqua solution they split, like calcium can split like this. Okay, I'll leave out this, then plus, then this one also can be like this. That's how we write it. Then plus this a hydrochloric acid splits like this to hydrogen ion, plus this chloride ion goes like that. Then the arrow goes like that. Then this one, which is an aqueous, will also split like calcium, will be like this, then plus, then the chloride ion will have a 2 here, then a negative there, then plus water like that. So this is an ionic equation. So in an ionic equation, we always cancel out ions that are present on both sides of the equation. Like here we have calcium, we cancel it with this one. Then also we have the chloride here. I didn't put a 2 here, so there's a 2 here. So this chloride and this one will cancel. So what are we remaining with? With a 2OH negative plus, then 2H plus, then this leads us to 2H2O. So when you look at this one coincides with B. So here the answer is B. However, these two can cancel, right? Because we have 2 common, so these 2 and that can cancel, so that we have OH negative plus H plus, then we get something like H2O. So see that this one and this one, they're the same, so our answer there becomes B. Okay, so that is that. So let us move on to the next question. So let me just clear out this one here so that I have space for other things. Okay, so now we go to A9. Says the equation shown represents the neutralization of aqueous sodium hydroxide with dilute sulfuric acid. Okay, so they are talking of this equation here shown, which is the sodium hydroxide plus sulfuric acid gives us sodium sulfate plus water. Then they're saying how much sulfuric acid is required to neutralize 100 cubic centimeters of 1.0 mole per cubic decimeters of sodium hydroxide. Okay, the equation shown represents the neutralization of aqueous sodium hydroxide with dilute sulfuric acid. Okay, so this equation they've given us represents the neutralization of aqueous sodium hydroxide with sulfuric acid to form sodium sulfate and water. Then they are saying how much sulfuric acid is required to neutralize 100 cubic centimeters of 1.0 mole per cubic decimeters of sodium hydroxide. So here they want you to find the correct amount that would be required to neutralize 100 cubic centimeters of and the 1 mole per cubic decimeters of sodium hydroxide. So for us to be able to find this question, or before we go there, this is one of the poorly questioned, or one of the poorly structured questions here, because it requires you to test all these values provided here for you to find an answer. You will not manage to solve directly using these without testing each one of these. So you need to test this one, test this one, test this one, test this one. If it is going to agree with what you are going to find here, then that's when you are going to choose the correct answer, and that would make you waste a lot of time on just one question that requires you to get just 1 mark. Look at that. So so now for you to answer this one, you have to convert 100 cubic centimeters of this into decimeters and then find the number of moles. Okay, so number of moles can be found from this formula. Concentration is equal to number of moles over volume. Make number of moles the subject of the formula, which will be number of moles is equal to concentration times the volume. So concentration is 1 times volume. You get 100 divided by 1000 to change it to decimeter cubed, so that it becomes 0.1. So times 0.1. When you multiply this, you get 0.1 more. So this amount is this in moles. Now for you to know how much moles, now these are the moles of sodium hydroxide provided here. Now we need to know how much moles, if you are provided these, how much more moles of this will be required of the sulfuric acid. Okay, so you are provided these of sodium hydroxide. How much more of this will be required? And once we know those moles, then we'll use this multiplication to see which one will match with those moles we'll find here. So for us to find the moles here, we need to use balanced mole ratios. Here we have a 2, here we have a 1. So say we have a 2 to 1 in this reaction. 2 moles of sodium with 1 more, 2 moles of sodium hydroxide with 1 mole of sulfuric acid. But we are provided for sodium hydroxide, we have calculated that the actual moles provided are 0.1. But here we want to know, if you have 0.1 now, how much more now will be needed out of this. So put x here, then we'll cross multiply. We'll say 2 times x to be 2x equals then 0.1 times 1, it will be 0.1. Now we want x, so here we divide by 2, here also by 2, so that 2 goes, so x is going to be 0.1 divided by 2, it will be 0.05 moles. So now you discover that these now are the moles of sulfuric acid that will be required to neutralize 0.1 moles of sodium hydroxide. Now if these are the ones, now what volume and concentration will give us this? What volume and concentration will give us this? So now we'll start now multiplying each one of them. So this is what now you have to go through. That's why I said these are one of the poorly asked questions in an exam. So we'll start by first saying, okay, this 25 divided by 1000, so that it becomes 0.025. Now let's multiply that by this concentration of 0.5. What are we getting? We are getting 0.0125, which is not equal to this, so A is not an answer. So we come to B. B, we have 50, change it to 1000 to cubic decimeter by dividing by 1000, so it becomes that 0.05. Then 0.05 times 1 times 1, what are we getting? We are getting 0.05, which is equal to this. So this entails us that the correct answer here is actually this same B here, because when you multiply this and this, we are getting this one as the number of moles, so meaning these are the quantities. Now this is why I said it is a poorly asked question, because you do a lot of work for you to get an answer which requires you just to obtain 1 mark. Okay, so let's move to another question, which is 10. A10 says a solution containing 0.5 mole of solute and 250 cubic centimeters of solvent was used in an experiment. What is the molar concentration of the solution? Okay, let's start again. A solution containing 0.5 mole of solute and 250 cubic centimeters of solvent was used in an experiment. What is the molar concentration of the solution? Okay, so they want just concentration. So concentration, which is C, is equal to number of moles over volume. So we have been provided number of moles as 0.5 mole. So say, okay, concentration is equal to number of moles 0.5 divided by, then volume, we have been given 250 cubic centimeters. However, this is in cubic centimeters. We change it in decimeter by dividing this by 1000 so that it becomes 0.25. So this one becomes 0.25. Then you divide 0.5 by 0.25, you get 2 more per cubic decimeter. So meaning that our correct answer will be C here. Then we go to question A11. A11 reads, which of the following graphs shows the change of volume of carbon dioxide evolved over time during a reaction between calcium carbonate and hydrochloric acid? Which of the following graphs shows the change of volume of carbon dioxide evolved over time during a reaction between calcium carbonate and hydrochloric acid? Okay, so these graphs here, the one that indicates a volume and time should have volume on the vertical axis, time here, and during production, to evolve it is to produce. So when calcium and hydrochloric acid, they are reacting, one of their products is carbon dioxide and the other one is calcium, actually chloride. Now this carbon dioxide is a gas, so at the start of the experiment you expect there not to be carbon dioxide. But as the reaction proceeds, the carbon dioxide level will start rising, and then as the reaction ends, then the production of carbon dioxide will stop. So the correct graph will be this one here, which will indicate at the start of the reaction, the volume and time are 0. As time starts moving and volume, they'll start going upward. And when the reaction ends, the level of carbon dioxide stays the same there, meaning that production of carbon dioxide has stopped. So this is the correct answer. Then we come to A12, which says when an element loses 2 electrons, it A becomes unreactive, B reduces its mass number by 2, then C reduces its proton number by 2, then D retains its relative atomic mass. Yeah, so when an atom loses 2 electrons, its relative atomic mass stays the same. Okay, so 13 says an element X forms an ion X with a charge of -3. In which group of the periodic table will this element be found? An element X forms an ion with a charge of -3. In which group of the periodic table will this element be found? Okay, so for an element to have a charge of -3, it means that it had gained 3 electrons in its outermost shell for the outermost shell to be full. So if it gained 3 electrons, it means that it had initially 5 electrons in the outermost shell. So if it had 5 electrons in the outermost shell, then the group in which it belongs is actually group 5, because the number of electrons in the outermost shell is equal to the group number in which the element belongs. Okay, so what I'm saying is that for this element to have formed a charge of -3, it must have gained 3 electrons in its outermost shell for it to become stable. So for it to have gained 3, it means it had initially 5 electrons. So to 5 electrons, you add 3, it becomes 8 for it to be full. Now since it has 5 electrons initially in the outermost shell, then it is in a group 5, because the number of electrons in the outermost shell equals to the group number in which the element belongs. So here the correct answer is group 5, which is C here. Okay, so this one actually moved. It is supposed to be this one here, group 5. Okay, yeah, group 5 here. All right, so let's move to the next question. So question A14 says compound Q is a crystalline solid at room temperature and pressure. An aqueous solution of Q is tested as shown in the following table. So we have compound Q, which is crystalline solid at room temperature and pressure. An aqueous solution of Q is tested as shown in the following table. So they get this one, they test. So how did they test? Acidify with dilute nitric acid, then add the aqueous barium nitrate. Test result, what they saw after acidifying this with the dilute nitric acid and then adding aqueous barium nitrate. Result, no visible change. What happened? Add aqueous ammonia. So to this same one, they added aqueous ammonia. Test results, they saw white precipitate soluble in excess. So a white precipitate was seen, and it was soluble in excess. Then the question says, what could be the identity of Q here? Okay, so this question is coming from qualitative analysis, which I covered very well in my online tuitions. If you're a grade 12 learner, you haven't understood very well qualitative analysis, you can join my online tuitions so that you can access these lessons. They are top-notch lessons, second to none on the internet so far. All right, so if you get these online lessons, you will be able to understand how qualitative analysis works. And also for those doing GC online lessons for quick revisions, you can actually join by WhatsApping me on 0977924175 so that you can get access to the online revisions. Okay, so here the correct answer is actually a D here. All right, so we move on to question A15, which says, what happens when a strip of silver is immersed in an aqueous solution of copper 2 sulfate? What happens when a strip of silver is immersed or dipped in an aqueous solution of copper 2 sulfate? Okay, so strips of silver is like a metal sheet of silver that is dipped into a solution of copper 2 sulfate. So this is just an experiment that they are doing on displacement reactions to determine which metal is more reactive. Okay, so when you look at the reactivity series, you compare copper and silver, you see that copper comes first before silver. So copper is more reactive than silver. So if you get silver and then you react with a compound of copper, silver will not displace copper from its compound, and therefore nothing will happen. Okay, when they say what happens when a strip of silver is immersed in an aqueous solution of copper 2 sulfate, bubbles of gas will appear, nothing, no reaction occurs. Yes, so the correct answer is actually B there. Then A16 says, identify one thing that is common among the molecules of these gases, oxygen, hydrogen, and nitrogen. Identify one thing that is common among the molecules of these gases, oxygen, hydrogen, and nitrogen. They all exist as diatomic molecules, which is correct so far. All have same relative atomic masses, wrong. All support burning, wrong. All are all found in group 5, which is wrong. So the correct answer is A. All exist as diatomic molecules. All right, so let's move to the next question. So the next question is A17, says the diagrams show the electronic structures of 4 elements. We have element 1, this is electron key structure, 2 electrons in its outermost shell and 2 electrons in its innermost shell. Then element 2, we have it has how many? 7 electrons in its outermost shell and 2 electrons in its innermost shell. Element 3 has got 8 electrons in its outermost shell and 2 electrons in its innermost shell. Then element 4 has got 4 electrons in its outermost shell and 2 electrons in its innermost shell. Then here they say identify 2 nanometers from these structures. Okay, so for us to be able to identify nanometers, 2 nanometers, we need to know that usually metals have got 3 and less electrons in their outermost shell. So the maximum number of electrons in outermost shell of metals is 3. That's what I know. Then for nanometals, they start from 4 going upward. So when we look at this one has actually 7 electrons in its outermost shell, so it is a nanometer. And this one again, it has actually 4 electrons in its outermost shell, so it is a nanometer. But 3 has got 8, so we don't know this for 3 because it has 8. We don't know whether it lost some to remain with this shell, or maybe it gained some to have this shell. So the correct one, which can give us understanding of nanometers, it's this one, which is not 4. So when you check from the periodic table, you discover that this one actually is chlorine, and then this one is actually should be carbon 1, 2, 3, 4, 5, 6, which are nanometers. So these questions like these, they are free marks. Sometimes go to the periodic table and check. Once you check from the periodic table, you count the number of electrons here, you see that these are nanometers. So the correct answer is actually 2 and 4. So the correct answer was D, 2 and 4. So we move to question 18, which says which substance reacts with steam. Again here I saw like 2 answers, because in steam reformation we use methane to form hydrogen gas. So we can react methane in steam reformation so that it can form hydrogen gas. That's what happens there. And also this this ethene also here can undergo hydration, where we use to form alcohol. So when they say which substance reacts with steam, I found 2 answers for me here. I may be corrected by others, but that's what I saw. So yeah, then we go to 19. A19 says the organic compound X and Y react to form another compound, another organic compound Z. So we have the organic compound X and Y react to form another organic compound Z. So this is an ethanol with this functional group, and this is actually an acid with this functional group of COOH. Now the question says what are the names of X, Y, and the product Z. So this with the how many carbon atoms? 1, 2, 3. This one should be propanol. Propanol, yes, propanol, which is an alcohol. Then this one with the 2 carbon atoms, this one should be ethanoic acid. So X should be propanol, then this one should be ethanoic acid. Now if propanol and ethanoic acid react, they should form an ester, which is ethyl propanoate. So it should start with this ethyl propanoate. So the correct answer is C. I covered organic chemistry. For those interested in online tuitions, they can access also organic chemistry lessons in my online group by contacting me on WhatsApp number 0977 9241 75. All right, so let's move to question number 20, which says the following table shows methods of disposal of non-biodegradable waste and the accompanying reason. Which is the best match for the waste, method of disposal, and reason? The following table shows methods of disposal of non-biodegradable waste and the accompanying reason. Which is the best match for the waste, method of disposal, and reason? Okay, we have waste, method of disposal, and reason. Okay, so waste, we have metals, method of disposal, dispensing them at the dump site, reason, cleans the environment. Is it true that when you dispense metals or deposit metals at the dump sites, then the environment becomes clean? This logically does not make sense. Then B, waste, let's say we have metal can, method of disposal, recycling, reason, prolongs the lifespan of metal reserves. Yes, this one makes sense, because when you are recycling metal cans, then the metal reserves in the soil or in the ground are prolonged. Okay, so this one makes sense. Let's look at the plastic as the waste, method of disposal, burning, then reason, cleans the environment. Does burning clean the environment? No, it brings pollution. Then we come to plastic again, method of disposal, burning, then reason, cleans the environment. I don't think it does. It also pollutes the soil. So the correct answer should be B here. We move to section B, 45 marks. Answer all questions in this section Write your answers in the spaces provided in this question paper. B1, the following data was obtained from 3 bottles A, B, and D. C suspected to contain fruit juice, vinegar, and ammonium hydroxide. Okay, we are told the following data was obtained from 3 bottles A, B, and C suspected to contain a fruit juice, vinegar, and ammonium hydroxide. So we have bottle A, B, C. pH for bottle A actually is 11.7, which is above 7, which means this one was alkaline or basic. Then B 7.2, which is a little bit above water, which is a little bit neutral. Then this C is actually has a pH of 5 less than 7, which is actually pH for acids. Now when they say A, which of the bottles contain the Roman 1 fruit juice? So juice, a fruit juice shouldn't be basic, shouldn't be acidic, it should be this one here. Okay, so bottle B. Then ammonium hydroxide. Ammonium hydroxide, this ammonium is basic. So which bottle contains something which is basic? Should be this one with a pH of 11.7, which is bottle A. Then we move on to part 2 here, or 3, vinegar. Which one contained vinegar? So you must understand here that actually vinegar, this vinegar here, vinegar is an acidic. So since vinegar acidic, so it is bottle C here. So definitely it is bottle C. Then B, they're saying the contents of bottle A and C were mixed. Then Roman 1, identify the type of reaction that occurred between solution A and C. Type of reaction. So we are told C and D, A and C were mixed. So C is vinegar, which is an acid. Then A is ammonium hydroxide, which is a base. So when a base and an acid react, that type of reaction is called what? Neutralization. Then part 2, they are saying describe what you would do to find out if the reaction is exothermic or endothermic in nature. So if this reaction between vinegar and ammonium hydroxide is endothermic or exothermic, what would you do to find out that? Look, so they gave 3 marks. Look at the answer space they provided. This is why I'm saying I don't know what is happening in science. These examiners, I don't know what they're thinking. Look, the space they provided for someone who should describe what you would do to find out if the reaction is exothermic or endothermic in nature. You just put a small line and 3 marks. You expect someone to describe on this line? Come on guys, let us be serious in science. This is disappointing. Look the answer which you need to give, because you want to find out whether this reaction is exothermic. So this is how you answer. Use a thermometer to measure the initial temperatures of solutions A and C before mixing. Then mix the solutions and measure the temperatures of the mixture immediately after mixing and over a short period. If the temperature of the mixture increases, the reaction is exothermic. If the temperature of the mixture decreases, the reaction is endothermic. Now, this is how you should answer according to the question for you to get these 3 marks. Now, this cannot fit here. Okay, so be careful even as you go in an exam. You must expect such errors to happen where they've given you less space. So make sure you become careful when writing. Know that is going to happen. So this is how you should answer this question. So we go to B2, says hydrogen gas can be produced on a large scale by reacting methane and steam. You have seen that question where I told you that they had to put 2 answers. There's a question I told you that they had to put 2 answers. Let me show it to you. This one here where they said which substance reacts with steam. I told you that methane and this one, both these they do react with steam. That's why I said two options here, like you can see proven by this, where they've said that hydrogen gas can be produced on large scale by reacting methane with steam in a process called steam reformation, as shown in the equation, or steam reforming you have seen. So if you get methane plus steam, you can get hydrogen gas and the carbon monoxide there gas. So I don't know what is happening, guys, when these guys are setting, just to make sure that other people's children fail, trying to twist questions in the process, they are making errors. Okay, so let's see here. They're saying hydrogen gas can be produced on a large scale by reacting methane and steam in a process called steam reforming, as shown in the equation. So this is methane plus steam gives us hydrogen plus carbon monoxide. Then here they're saying given that 120 cubic decimeters of methane reacted, calculate the volume of hydrogen gas that was produced at room temperature and the pressure. Okay, so given that 120 cubic centimeters of methane reacted, calculate the volume of hydrogen gas that was produced at room temperature and pressure. 2 marks. Again, here the space is too small for someone to do calculations. So here they should have left a bigger box for someone to do calculations for. Because let me show you the calculation that will go here. So I did like this. Okay, so this equation must be balanced. It is balanced as it is. So here we have been given 120 cubic decimeters of methane which reacted with steam. Then they are saying calculate the volume of hydrogen gas that was produced at room temperature and pressure. So they need this amount of the amount of hydrogen gas produced here, when methane given here was about 120 cubic decimeter. So for you to be able to answer this question, you need to use that rule which says at room temperature and pressure, if you have 24 cubic decimeter will give you 1 mole of a gas. If you have this volume will give you 1 mole. Okay, that's what happens. Okay, so 24 cubic decimeter will always give you 1 mole. Now let's find out if you are given 120 of this. Let's convert it in mole first. So you say 120 will give us how many moles? You cross multiply. So 24 times x, it will be 24x equals 120 times 1, it will be 120 cubic decimeter mole. So divide by 24 cubic decimeter, also by 24 cubic decimeter, so that these will cancel, remain with x is equal to this. So 120 cubic decimeter, so this and this will cancel. So 120 divided by 24 will have 5 moles. So in short, this 120 of methane is equivalent to 5 moles. Now that we know that, now we'll go to equation here. So you see the calculation, the way they are moving and the space they give. That's why I say the space is too small. So once you do this, this is how you do it now. So in this reaction, the reaction is balanced and it is 1 to 1. 1 to 1. So it means that in this reaction, when you have 1 mole of methane, it always reacts with 1 mole of steam here. I mean, 1 mole of methane will always go with 3 moles of hydrogen. That's how this equation is moving, because you have this and this which you are asked. Now in reality, they have provided 120, which is equivalent to these 5 moles. So say, but we have 5 moles of methane. So how many moles of now hydrogen gas will be there? You say x. Okay, sorry, I didn't put x there. So say x, then you cross multiply. You say 1 more times x, you have x, then equals, then 5 more times 3, you have 15 moles. So now that you have that 15 moles, it means that if you have 5 moles of this, here to give you 15. So you have seen, because here it's like you have 5 moles, here it is 3, so that 5 is multiplied by 3, so 15 moles. It makes sense. Now these 15 moles, now it is the one we need to calculate to change into volume. Now change it back to volume, because they're saying calculate the volume of hydrogen gas that was produced at room temperature and the pressure. So what we can do now here is to say, okay, we know at least the number of moles of hydrogen gas that were formed, which is 15 mole. Now at room temperature and pressure, what that could be in volume. So there now you can say, okay, you use the same relationship here where you say 1 mole always is equal to 24 cubic centimeters. Okay, so 1 mole is equal to 24 cubic centimeters. Now how about 15 moles? It is equal to what? You put x here, so you cross, so you say 1 more times x, you have x, then this times that, you get that value there. So meaning that this will be the answer in volume. So say therefore 360 cubic centimeters of hydrogen gas is produced. Now look at the calculation that we have done for us to get this answer and the space which they provided. So guys, be careful as you go in an exam, go with that mind to say the spaces somehow will be very limited and you have to solve somewhere. You have to be careful. You ask maybe for those other papers they give, you ask for the one that will just be using to make sure that you solve, so that this space you don't mess it up, you utilize it very, very well. Okay, so that is that. Now we come to B, which says hydrogen is used in the Haber process to produce ammonia, which is used to make ammonium fertilizers. Eutrophication is one of the bad effects of using ammonium fertilizer on the environment. Okay, let me read again. Hydrogen is used in the Haber process to produce ammonia, which is used to make ammonium fertilizers. Eutrophication is one of the bad effects of using ammonium fertilizer on the environment. Part 1 says explain what happens during eutrophication. 4 marks. Again, explain 4 marks, 3 lines. Are these guys serious? Not serious, sure. So when they are saying children are really failing, I'm sure even teachers we are to blame in this case. If at the Examination Council of Zambia the level of analysis in terms of questioning is this level, how much more in schools? Okay, I mean we should be very serious. 4 marks cannot demand just 3 lines to explain what happens during eutrophication. I don't think so. Okay, so okay, anyway, eutrophication is this process here where there's buildup of nutrients in an aquatic environment, and that buildup of nutrients results into growing of materials like this one here called algae here. So this is how you explain it. Now you say eutrophication is the process where an aquatic ecosystem becomes enriched with nutrients like nitrogen and phosphorus, leading to an increase in the growth of algae and other aquatic plants. So this is how I had actually summarized it. So now here part 2 says suggest one way of minimizing eutrophication, how this process can be minimized. So the answer was that one way to minimize eutrophication is to reduce nutrients runoff into water bodies or avoid doing agriculture activities along rivers. Yeah, because doing agricultural activities along rivers causes runoff of nutrients into the rivers, and this causes eutrophication. So one way to minimize eutrophication is to reduce nutrient runoff into water bodies. Okay, so we come to B3. A says differentiate chemical changes from physical changes. So differentiate chemical changes from physical changes. Okay, so we must know that chemical changes results in the formation of new substances with different properties, while physical changes alter the form or appearance of substance without changing its chemical composition. Then B, classify the following processes as either physical or chemical change. Part 1, condensation of steam to water. So condensation of steam to water, is it a chemical change or physical? It is a physical change. Then part 2, rusting of iron. Is rusting of iron a physical or chemical change? It's actually a chemical change. Then part 3, photosynthesis. Is it a physical change or a chemical change? It's chemical change. Then let's move to B4. Says halogens are diatomic. Halogens are diatomic. What does the term diatomic mean? So here we are saying the term diatomic means consisting of 2 atoms. Then B, differentiate the bonding in iodine from that in magnesium oxide. Okay, so magnesium oxide is an ionic compound, while iodine form a diatomic molecule consisting of a covalent bond. So what we can simply say here is that when they say differentiate the bonding in iodine from that in magnesium oxide, we can say that the bonding in iodine involves covalent bonds, while bonding in magnesium oxide involves ionic bonds. Then C, chlorine gas is bubbled through potassium bromide solution in a test tube until there is no more change. Right, part 1, a balanced chemical equation for the reaction. Okay, so we are seeing here that the chlorine is being bubbled through potassium bromide. So here also we are studying a displacement reaction for substances in group 7. Okay, so when we look at the periodic table, we discover, when we look at periodic trend, we discover that those elements above other elements in a group of nanometals like group 7, they are more reactive than those below them, and they displace the elements below them from their compound. So like chlorine, when it reacts with potassium bromide, chlorine can displace this bromide to form potassium chloride. So that's what would happen. So when they say we write a balanced chemical equation for the reaction, we should take note of that. So when we have this chlorine gas which is reacting with potassium bromide, it should now give us potassium chloride plus the bromide will come out as a gas. So if it is balancing, we know that chlorine is 2 here, chlorine is 1 here, so we can even put a 2 here to make it 2. Then again here we have seen that bromide is 2 here, or we can say that potassium is 1 here, here it is now 2 because of these 2, we can put 2 here. Now bromide is 2 here, and here it was already 2, so it is balanced. Then they're saying we also write an ionic equation for the reaction. So an ionic equation will just involve cancelling ions that might appear common. Like here you discover that what will appear common here will be actually, if you write them in ionic form, it will be actually potassium will be common, and here, so it is the one that is going to cancel. That's what is going to happen when you do an ionic equation. So if it cancels out potassium there, then you will remain with this as an equation. So you have chlorine plus you have bromide 2, then equals here you have chlorine 2 plus bromide gas there. That would be the final ionic equation. Then D, state 1 observation you would make at the end of the reaction. So this is the observation. So color change from colorless to brown. Okay, because this bromide is quite brown, chlorine is quite colorless also as a gas, but when you bubble it through here, and this potassium bromide is colorless, so when you bubble it through here, it will form this bromide which is brown. So you can see a color change from colorless to brown when this bromide is formed as it is being displaced from here. Then we move on to B5, which says an element M in group 1 and period 3 of the periodic table reacts with the element N in group 6 and period 2 of the periodic table. Then they say A part 1, draw a dot and cross diagram to show the bonding in the compound formed between element M and N. Use the letters M and N and show outer shell electrons only. Okay, so we have told this element M, which is in group 1, and period 3. So when you go to the periodic table, let me see if I can get the periodic table here on my computer. If I can search the periodic table. Okay, so when we look at the periodic table, this is group 1, this is group 1, and period 3 is period 1, period 2, period 3. So the element which is in group 1 and period 3 is sodium. Then when we come back to the question here, we are told group 1 period 3 of the periodic table reacts with the element N in group 6 and period 2. So again we go to group 6. So if we go to group 6 is here, this is group 6 and period 2. So group 6 is this one, and period 1, period 2 is this one. I'm sure this one here, yeah, which is oxygen here. That I'm very sure of, because that's what it is saying here. So that should be oxygen. So oxygen has got how many electrons? It has about 8 electrons, 2 in the first shell and 6 in the last shell. So the sodium and the oxygen that are reacting. So that one you should know. No one should restrict you from using the periodic table. No, you can use the periodic table in any exam. So here when they say draw a dot and cross diagram to show the bonding in the compound formed between elements M and N, use the letters M and N and show outer shell electrons. So you start doing the bonding. You write element M, so they need electrons in the last shell only. So for sodium, it loses 1 electron, so it will remain with 8. So you use dot here, you put 8 in the last shell for sodium. Then if it loses 1, then it forms a positive charge of 1. So this is sodium. Then for oxygen, it will gain how many? Actually it gains 2 because it has 6. So I must have made a mistake here. So it will gain 2, 2, 2. Here it should have 2. Okay, so let me change. Here it should have 2 to show that it gained. In fact, they have to be 2 of them. Yeah, so it gained 2 here. So here now I'll remove this one and put one of these. Yeah, then what I'm going to do again is to put a 2 here. Okay, I'm showing you now the process that I'm doing now, because I've realized I made a mistake. I have to put a 2 here. So I'm explaining now. So this is how it is going to be. So this will be actually oxygen, which has 6 electrons in the outermost shell. So for it to be stable, it gains 2 more, like these. So these are 2 more which it gains. So now let me just arrange these things properly, because I've seen that they're not well arranged. So let me do this. So this one should be maybe among this one, and I'm just trying to do the arrangement properly. Then this one should be 2, then that one should come after that one, I think. Let me try to put it this way. Yeah, so yeah, that is how it is going. So those are 2 like that. So these will be 2 electrons which will come from sodium. Now remember, sodium has got 1 electron in the outermost shell, so it loses only 1, but here this one needs 2, so there will be 2 sodium atoms here to contribute, each one 1 1. That's why here it will be 2 like this. Then we close it. Now since this one gains 2, here to have a positive charge of 2, not 1. So here I can change Again, I should put a 2 there like that as the charge. Yeah, so that would be the answer, guys, like that. Okay. Yeah, so this is the answer for this one. Now part 2, they say what type of bonding exists in the compound. So the type of bonding here, it is ionic bonding, because it involves a metal and a nanometal, and there's a transfer of electrons. So these electrons, they came from 2 sodium atoms. Then part 3 says if the compound formed is soluble in water, describe what you would do to show whether it is acidic or basic. Your answer should include expected results. 3 marks. Okay, so here you say dip blue and red litmus papers in the solution. If blue litmus paper changes red, then it is acidic. If the red litmus paper changes blue, then it is basic. So this is how you put it. Then you come to B6. The following list shows the names of some metals in the reactivity series. We have iron, potassium, magnesium, zinc, and copper. Then A, state in each case which one of these metals is most likely to part 1 occur mostly and combined in the Earth's crust. Then part 2, react slowly with steam to produce hydrogen gas. Then part 3, react vigorously with cold water. Okay, so we have these elements: iron, potassium, magnesium, zinc, and copper. So the metal that can or is most likely to occur combined among these given here, it can be copper, though copper doesn't occur like that. But why I'm saying so, because when we compare these iron, potassium, magnesium, zinc, and copper, the least reactive metal here is actually copper. But copper, when we study our reactivity series, it is not found among those elements that are found and combined. So the ones that are found and combined are gold, silver, and mercury. These are found and combined in the Earth's crust, but copper, going upward of the reactivity series, we see that these others get combined because they are reactive. But however, according to this question, the one that is less reactive is copper. So when they say state in each case which one of these metals is most likely to part 1 occur mostly and combined in the Earth's crust, so here it should be copper. Then part 2, react slowly with steam to produce hydrogen gas. So copper does not react with steam, but iron can react slowly. However, iron with zinc and magnesium, it reacts fast. But I mean, steam with zinc and magnesium reacts faster, but with the iron slowly. So we can put iron here. React vigorously with cold water. Among these, the one which is most or very reactive is actually potassium. So potassium will react vigorously with cold water. Then B, they are saying aluminium will react with zinc chloride on heating, but not with magnesium chloride. Okay, write the names of the metals starting with the most reactive at the top and the least reactive at the bottom to include aluminium. Okay, so we are told that aluminium will react with zinc and then not magnesium. So if aluminium will react with zinc chloride, it means it will displace zinc from zinc chloride and form aluminium chloride and zinc. But if you get aluminium, you react it with magnesium oxide chloride, it wouldn't react because aluminium is not going to displace magnesium. So with this addition of this information, they want us to write the names of the metal starting with the most reactive at the top and the least reactive at the bottom of the include aluminium. So we have how many? 1, 2, 3, 4, 5. Now we should also include aluminium. So aluminium in this case should become below magnesium but above zinc. So in this arrangement we can have potassium, magnesium, then aluminium, then zinc, iron, copper. So that's how it is going to be. Potassium at the top, then magnesium. I've used the symbols. So potassium, okay, then magnesium, then aluminium, then zinc, then iron, then copper. So this is the order of reactivity. Most reactive at the top, least reactive at the bottom. Then C, magnesium reacts with dilute nitric acid to form magnesium nitrate and hydrogen gas. So magnesium reacts with nitric acid to form magnesium nitrate and hydrogen gas. Then they're saying, what is the effect of increasing the concentration of hydrochloric acid on the rate of the chemical reaction? Explain your answer. So the effect of increasing the concentration on the rate of chemical reaction is that concentration increases. Increase in concentration increases the rate of reaction. So that's the effect here. So you're saying the rate of chemical reaction increases. Then explanation will say this is due to increased collision. Okay, here it should have been D. So let me just put D here. So this is due to increased collision resulting from increased moles of nitric acid. So when moles of nitric acid are increased due to increase in concentration, there will be an increase in rate of chemical reaction. Then B7 says alkenes are said to be unsaturated hydrocarbons. Part 1, explain the meaning of unsaturated hydrocarbons. So here we are saying unsaturated means reacting owing to double bond between, so unsaturated means reactive owing to double bond between carbon to carbon, which acts as site of reaction. So in alkenes they are double bonds. So because they have double bonds, they are said to be unsaturated. So unsaturated means reactive owing to double bond between carbon to carbon, which acts as site of reaction. Then part 2, distinguish between ethene and ethane. So what is the difference between ethene and ethane? So we can say that ethene has double bond between the two carbon atoms, while ethane has a single bond between the two carbon atoms. Then B, they're saying polyvinyl chloride is a polymer whose monomer is vinyl chloride or chloroethene. So this polyvinyl chloride is a polymer whose monomer is vinyl chloride or chloroethene. This is the monomer. They left a carbon here, of course. I don't know what happened with their typing. Then part 1, they're saying draw a diagram to show part of a polyvinyl chloride polymer containing 3 vinyl chloride monomers. So monomers are small molecules of a polymer. These are basic units of a polymer. So like if this one was a monomer in a polymer has got a single bond. Like this bond here can break here and break here. There will be one bond here. So like here I can make one of this one here to be single bond. Here I'll put a bond here. So then I'll put a bond here, a bond here. So this line which I'll break, I'll remove from here. Part will come here, part will come here. Okay, so this carbon, they forgot I have included it. Then you put this one here. So hydrogen, 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 chlorine there. Then in a polymer, these there should be 3 of them. So there'll be another one here of this same, another one here. So there are 1, 2, 3. That's what they mean when they say draw a diagram to show part of a polyvinyl chloride polymer containing 3 polyvinyl chloride monomers. Okay, so this is how they should have done it, and should have given you 3 marks, or I mean 2 marks for doing that, other than giving you 1 mark anyway. Then part 2, they're saying give one reason why polyvinyl chloride is used as an insulator, electrical insulator. So if it is used as an electrical insulator, same, because as a plastic it is a poor conductor of electricity. Then we move to section B. Section C, I mean 20 marks. Answer any 2 questions from this section in the separate answer booklet provided. C1, the flow diagrams the flow diagram shows how lime is manufactured. Okay, this one I taught it in my online tuitions very well, and I'm sure I predicted it previously in the last exam, that prediction which I made. So let's read. The diagram says the flow diagram shows how lime is manufactured. Then in this flow diagram we have substance X undergoes decomposition of substance X. We have carbon dioxide, calcium oxide. Then this calcium oxide undergoes hydration of calcium oxide. We form substance X. Then this substance X undergoes process A, forms a substance Y. Okay. Then A, they're saying A part 1, name substance, name process A. So this substance, it is a calcium carbonate which undergoes decomposition to give us a calcium oxide and some carbon dioxide gas. So this calcium oxide, when it undergoes hydration, you add water to it, it forms calcium hydroxide. Then calcium hydroxide, when you bubble carbon dioxide in it, it gives back calcium carbonate. So this process, which leads to formation of calcium carbonate, it can be called precipitation. Okay, so I'm going to give answers. Then part 2, they're saying write a balanced chemical equation for process E. So let me just go to this B here. Describe how substance Y would be used to test for the presence of a named gas. So how can be substance Y be used to test for the presence of a named gas? Okay, then C part 1, give a metal that would be purified by substance X after its extraction. Give a metal that would be purified by substance X after its extraction. Then part 2, write a balanced chemical equation that shows reduction during extraction of the metal you have given in C part 1. Then D1, state one use of a named alloy of the metal you have given in C1. Then part 2, other than alloying, how would you prevent the metal you have given in C part 1 from corrosion? Okay, so we have seen that they have mixed one question. This one question has 3 parts. Carbonates, it has extraction of metals. Here, extraction of metals. There are 2 parts for extraction of metal. Give a metal that would be purified by substance X after its extraction. Then here, write a balanced chemical equation for that shows the reduction during extraction. Then state one use of the alloy, so it is still an extraction, and then on corrosion. So this is how they bring a question. Sometimes you will not expect a question to come from one topic. It can come from different topics mixed together in one. That's why you need to know mostly all the topics, because when they mix them like this, some of the questions you won't be able to answer them if you concentrate on one topic. Now, in answering now this one, C1, C part 1, we are trying to answer this question here. Okay, I'm here, so we are trying to answer this part here. So CA1 process, name process A, this one which I told you that this process A, it will be precipitation. Then we come to part 2. Part 2 here, they are saying write a balanced chemical equation for the process here. This process, precipitation, so it is coming from calcium hydroxide to calcium carbonate. So here it will be like this. So calcium hydroxide plus carbon dioxide, it will give us calcium carbonate. So this is a balanced chemical equation. Okay, so let's see. It is not yet balanced, so I missed something here, so I need to add plus water here. So plus water. So I will do like this. Yeah, so now let's see what's going on now. Can't see my mouse anyway. Can you hide wherever it want to hide? That I'll do my thing. So there it is at 10. There it is take it at 10. After 10, then I'll get the plus there. Okay, then the plus there again. The plus should come after 10 there again there. Okay, so let me see now if it is balanced, cause if I check on hydrogen 2 oxygen oxygen 4, yeah, so this one now is balanced. Yeah, so this is the balance equation. So like that. So this is a balance equation. We have calcium 1, oxygen 2 plus 2, 4. Here 1 plus 3, 4. Yeah. Then hydrogen 2, hydrogen also 2 here. Carbon 1, here carbon 1. Yeah, it's balanced. So this is the equation. Then we come to B here. When you check B, sorry, it's going on now. When we come to B, here, they're saying describe how substance Y would be used to test for the presence of a named gas. Okay, substance X is used to find the presence of a named gas, which is carbon dioxide. I don't know why they had to hide that gas, because you hide it like this. If that gas you want to identify it again, they should have just said describe how substance X would be used to test for the presence of carbon dioxide, but they said a named gas for me. Okay, so here this is how you can answer. You can say when carbon dioxide is bubbled through substance Y, which is lime water, the solution turns milky due to the formation of calcium carbonate. So when this is bubbled here, this one turns lime milky due to the formation of calcium carbonate here. Okay, so then we move to the C part 1, which says give a metal that is used that would be purified by substance X after its extraction. So decomposition of substance X. So substance X is actually calcium carbonate. So calcium carbonate is used in the extraction of iron. So here C part 1, that metal is iron. Then part 2 says write a balanced chemical equation that shows reduction during extraction of the metal you have named in C part 1. So let's write a reduction reaction for iron. So iron is like this plus carbon monoxide. It gives us the metal iron plus carbon dioxide. So to balance, you put 2 here, you put 3 here, you put 3 here, then it is balanced. This is the equation. Then we go back to the other question. Says D1, state one use of a named alloy of the metal you have given in C. So one alloy that we know is mild steel, which is used for making car bodies. The main alloy is stainless steel is one of the alloys. High speed steel is one of the alloys of carbon. So you can also talk of those. Okay, manganese is one of the alloys of iron. So you can look at their uses, like in making cutting tools, utensils, and so forth and so on. Okay, then we go to the other part here. State other than alloying. Other than alloying, how would you prevent the metal you have given in C1 from corrosion? So how do we prevent like iron from corrosion? So apart from alloying, it is through painting and galvanizing. So when you paint iron or you do galvanizing, iron can be prevented from corrosion. Then let's go to C2, which says study the flow diagram shown and answer the questions that follow. So we have this flow diagram here. We have solution P reacts with zinc metal. It gives us solution Q plus hydrogen gas. Okay, so now if we have solution P, it reacts with a metal, it gives us solution Q and hydrogen gas. Then we have to know that any solution that reacts with a metal to give hydrogen gas, then that solution is an acid. So let's keep it in mind that this was an acid which was reacted with zinc metal to form zinc something and then hydrogen gas. Then here we are told the same P was reacted with aqueous silver nitrate to form a white precipitate, which is R. So then we'll start be thinking, if we form a white precipitate is an insoluble salt. So among the salts that we have that are insoluble, that I know, we have barium sulfate, lead sulfate, then we have silver chloride and the silver nitrate. Okay, so silver chloride and silver nitrate. Okay, so now you have seen silver chloride. There's a chloride there coming from the sulfate, from the hydrochloric acid. Then I talked of barium sulfate, lead sulfate. So those, they are insoluble salts. So if you have barium sulfate, lead sulfate, these are coming from the acid sulfuric, so they'll be insoluble there. But again, if you have barium sulfate can only give you something like what is this, can give you the sulfate salts, but here you have the nitrate ones and silver. So you cannot have silver barium, nothing like that, doesn't exist. So that one, it should be just a chloride that can react to give us silver chloride here. So for us to have a chloride, then here we must have a hydrochloric acid which reacted with this to give us a zinc chloride plus hydrogen gas. That's how we know that this one is hydrochloric acid. So here when they say identify R, this R here will be actually silver chloride. That's what I know. Then part 2, P here will be hydrochloric acid. Then here B, they say name the salt that would be produced if solution P reacted with the sodium metal. If solution P, which is hydrochloric acid, reacts with sodium, the salt that will be formed is sodium chloride. Then C, if they're saying what safety rule should Elena observe when carrying out experiment described in diagram, should put on protective equipment such as goggles and laboratory coats. Then in D, in which period of the periodic table is the non-metallic element in solution Q found? So that non-metallic element in solution Q, which is chloride, it's found in which period? It should be in which period of the periodic table? It should be period 3 if not mistaken. Then or period 2, we'll check on the periodic table. Then 3 describe how crystals of solution Q can be obtained from the solution. So let's begin answering this one here. So CA part 1. So this is the question. Identify part 1 R. We said R is silver chloride. That's what I said. So it will be silver chloride. Then 2, we are coming here where we need to identify P. I said this is hydrochloric acid, so this one will be hydrochloric acid. Then we come again here, B, name the salt that would be produced if solution P reacted with sodium metal. So if solution P reacted with sodium metal, I said sodium chloride. So so here I said it will be sodium chloride. Then we come back here, they're saying what safety rule should Elena observe when carrying out experiments described in the diagram. So here we are saying the most important safety rule when working with chemicals is to wear appropriate personal protective equipment such as safety goggles or glasses, gloves, and lab coat. Then we come again here, they're saying in which period of the periodic table is the non-metallic element D in solution Q found? Explain your answer. So here we said period 3 because it has 3 shells. Yeah. So when you look at even the periodic table is here, I gave it here. So chlorine is in period 3. This is period 1, period 2, period 3. So it's period 3 because it has 3 electrons in its outermost shell. Okay, then we look at this other question, which says describe how crystals of solution 4 or solution Q, this one, can be obtained from the solution. So how can you obtain crystals of zinc chloride? So this is a description that you need to give. So you need to say to obtain crystals of, sorry, here I made a mistake. I thought they're talking of zinc chloride here, so we need to put zinc chloride here. So we are saying to obtain crystals of zinc chloride from the solution, one would need to evaporate the water from the solution, allowing the salt to crystallize as the solution becomes saturated. Yeah, just like that. Then we move on to the other question, which is C3, says the following table shows the first 4 elements or 4 members of a particular homologous series. So we have compound, methanol, ethanol, propanol, butanol. Then molecular formula, these are the ones. Relative molecular masses, these are the ones. Then A, part 1 says name and give the molecular formula of the next member in the table. So they need the molecular formula of the next member. So maybe after butanol, the one that comes there, it's pentanol. Then determine the relative molecular mass of propanol. So propanol, we need to determine the relative molecular mass. Then B, ethanol can be manufactured from ethene, from either ethene or glucose. Then part 1, they're saying construct a chemical equation for the production of ethanol from ethene. So you see, ethene produces ethanol when ethene is reacted with steam. Like we saw that confusion there on the other question where I said there was a confusion there. Then part 2, using a named factor, explain how the rate of reaction for production of ethanol from ethane could be affected. Using a named factor, explain how the rate of production of ethanol from ethene, I think here it's typing error, ethene could be affected. Then C, calculate the maximum mass of ethanol that can be produced from 144 tons of glucose, 2 marks. Here again, they did it wrongly. It's supposed to be a lot of marks here. So let's start answering here. So here we are. So part 1, we are told to name and give the molecular formula of the next member in the table. So the next member is pentanol. So I'm going to say the next member is pentanol. Now for us to know the formula, we need to know the general formula for alcohols. So this is the general formula of alcohol. Pentanol has got the pentanol is 1 with the carbon atoms equal to 5. So pentanol, the molecular formula will be this. How do we get it? How do we get it? So we get it in this way, because if carbon here 5, we press 5 here, then here where there's N also we put 5 2 times that 5 10 plus this one 5, so 5. So this is pentanol, this is the formula. Using this, that's how we arrive at that. Then part 2 we come here, where on part 2 here we say determine the relative molecular mass of propanol. So what will be the relative molecular mass of propanol here? So the relative atomic mass of propanol, this one here, is to add the relative atomic masses of each atoms here. So here we have this. So here carbon, there's 12 here, hydrogen 1, oxygen 6, here 1. So we total them together, we have 12 times 3, 12 times 3 plus here it will be 1 times 7, it will be just 7 plus here oxygen 16, here 1. So when you total them together, you have 60. So we come to B. So B1, construct the chemical equation for the production of ethanol from ethene. So now from ethene, it is plus steam, it will give us ethanol like that. So the equation is balanced as it is. So ethene can react with this to give us ethanol, just as I mentioned in that question, which gave us confusion which one should be reacted with what. Then we come to part 2. So let's go to part 2. So part 2 here, we need to look at this question here. Using a named factor, explain how the rate of reaction for production of ethanol from ethane could be affected. So how can the rate? So we can say the rate of production, the rate of reaction for production of ethanol can be increased by using phosphoric acid catalyst. Then we come to this other question here. They're saying calculate the maximum mass of ethanol that can be produced from 144 tons of glucose. So this one they gave it 2 marks, but for you to be able to answer this question, you need to know the equation between that leads to the production of ethanol from glucose. Now remember, that equation that you need to give, it must be balanced. So balancing it already, it must be 2 marks. Okay, and then asking you to calculate it must be 2 marks. So this question alone required 4 marks. This is what I've been saying, poor questioning technique leading to failure in exams to the children, because there's no way you can bombard this question with 2 marks when you have not given them the equation. The first thing that they should have done was to give them the equation of production of ethanol from glucose. That equation should be balanced already, so that children use that equation to calculate this to calculate the maximum mass of ethanol that is produced from 144 tons of glucose. Now since this one has not been done, that it means that this has not been done well, so giving 2 marks is not enough. So now for me now to do this, I had to bring, this is the balanced equation that you need to use. From there you need to find the relative molecular mass of ethanol, it is this one. Then also the relative atomic mass of ethanoic acid, it's this one. You total these values here, then you multiply by 2, you get this. Then here you were given 144, here you say x, then you cross multiply this times that, you get 180x equals, then this times that, you get that, you divide by that, you divide by that, then you say x. So this is the number of tons. So therefore 73.6 tons of ethanol is produced. So this equation you have to write it according to them on your own. You balance it, then they will give you no marks, then they will only give you 2 marks for this. Okay, so guys, we have come to the end of this revision in chemistry. If you enjoyed it, give it a like and let me know in the comment section. For online tuitions, contact me on 0977 92 41 75. For now, bye and see you in the next lesson. Peace.